Every time we start a class, I need you guys to copy this part and write the date. Right, the date today will be 10/5, which is October 5th. And this is your purpose. This is called your purpose. And that's what you're doing today. Finding the mean absolute deviation. Okay. So before we even start, I'm going to go over a few things. Mean. And I want you to write this in your notebook, right? Add all the numbers in your data set right? And then divide the sum by the number, by the quantity of numbers added. For example, okay, let's say you had the numbers 20, 32, 53, I don't know, 75. This is just an example. So the first thing you would do, you would add right, you give me a total 20 plus 32 plus 53 plus 75, and you would get 180. And then 180 you divide by, there's 1, 2, 3, 4. Okay. And you would get 45. So the mean is 45. The mean is the average. Okay, that's another word for average. But what you need to know is that the mean, you shouldn't use the mean, you should not use the mean when there are outliers. So think of an outlier as a number that doesn't really belong to the group. So that's not a great example. Let me give you a better example. So let's say there's 13, there's a 13, there's a 14, there's a 15, there's a 17, and then there's a 75. This guy here, okay, is an outlier. Right? Can you see that he's very, very far away from the other numbers? So he's an outlier. So when you have a situation like this, don't use the mean. Okay, so the mean is good. You should use the mean when there are no outliers. For example, so if your numbers are, and I'll put it in this corner. So if you have number 12, let me change numbers. Let's say you had a 70, a 74, a 75, a 75, a 78. These are okay. You can use the mean here to find the average, right? Because there are no outliers. Okay. So the other measure of central tendency that we did is called the median. Median. So in English, median should remind me as the number in the middle. The number in the middle after you order your data from least to greatest. From least to greatest. Okay, so here's an example. You have numbers 5, 6, 7, 8, 9, 9, 10. So what's the number in the middle? So you have these 1, 2, 3, 4, 5, 6, 7. Yeah, 7 numbers, and you want to find the median. Who is the median? Okay, So the median is the number in the middle. So you go this way and this way, you're working towards the middle. 2, 7, 9, and this is your median. So 8. So the median is 8. Okay. So when is the median good? When should you use the median? Well, when you have numbers like this, let's say 5, and then you have 32, 33, 35, 36, 37. So imagine a data set with these numbers. The mean is good because you're looking for the number in the middle. So this and this goes away, this and this goes away. Right? And then we have, in this case, 2 numbers in the middle. So the number in the middle, how do we find them? You're going to do 33 plus 35, which in this case is going to be 68. And then 68 divided by 2 is 34. So the number in the middle is 34. So use a median when there is an outlier. Remember, an outlier is a number that's kind of far from everybody else, right? So look here, everybody is in the 30, 32, 35, 36, 37, and then there's this 5. This 5 really doesn't belong there, right? So again, when we find a median, we're crossing these, right? And who's in the middle? 34. So that's how you find the median. But you got to order it from least to greatest. And then we have measures of spread, right? Measures of spread that we talked about. And that's the range, which is the highest minus the lowest. And for example, let's say you had 12, 13, 15, 25, 29. Who's the highest number? The highest number is 29. And then who's the lowest number? The lowest number is 12. So the range is 29 minus 12, which is 17. So that's what we talked about, right? So now today, we're going to talk about something called mean absolute deviation. Right, that's what we're doing today. So mean absolute deviation, okay. I think this is a good example, and I'm going to ask you to pay attention to this one again. Okay, so look at these 2 classes. They took a test. Who did better on the math test? Well, if you add these numbers up, so let me add them up. So I'm going to do class 1 and then class 2 over here. So number 1 would be, let me add them up. All right, so 100 plus 100 plus 100 plus 100. We do a calculator. Plus 90 plus 60 plus 60 plus 60 plus 50 plus 50. Enter. I get 770. So class 1, 770. If I divide by 10, it's 77. So the mean is 77. For class 2, again, 100 plus 90, so let's add 100 plus 90 plus 90 plus 85 plus 80 plus 75 plus 70 plus 70 plus 60 plus 50. It's also 770. If you divide that by 10, you get 77. So the mean is 77. So again, these are 2 classes. They took a test. This is the results for class 1, and this is the results for class 2. So who do you think did better on the test? Class 1 or class 2? So we know the mean is 77, right? If you look at the class, here's the mean, 77 for class 1, number 1. This is class 2, and again, here's the mean, 77. Look at class 1. That's the average, right? Look how far these students are from the average. They're not really close to the mean. right? It's not consistent, right? Look at class 2. We have some people, some students close to the mean, don't we, over here? They're not as spread out. So there's less variety, right? The data is not as spread out as in class 1. So in class 1, the data is very spread. And in class 2, you can see that they are close to the mean. So mean absolute deviation is going to tell you which group, actually not group, it's going to tell you how close your data is near the mean, how close they are to the mean. So in this one, in class 1, the MAD, and we use M-A-D, the MAD is going to be big, right? Because look, they're so far away from 77. Now the MAD for class 2 is going to be smaller because these numbers here are closer to 77. These numbers over here are further away from 77. So let me draw you another picture here. So let's say I had these, right? And let's say the mean, put a flag, let's say the mean was 23. Right, so if you had your data like this, for example, the mean is going to be small, right? So not the mean, sorry, the MAD, the mean absolute deviation is going to be small. Why? Because everybody's close to the mean. Now if I gave you something like this, but again, here's the mean, it's 23, right? And I gave you some values. This one is going to have a big MAD. MAD is going to be big. Why? Look at the distance. Look how far. Right? Look how far they are. Right? And right here, they're really close. Look, they're close. Right? Or at least they're closer than the bottom one. Okay, they're close to the mean, and this one they're far from the mean. So let's take care of our first example. So we found the mean. The mean was 770 divided by 10, which is 77. Right, so what we're doing here is pretty much we're doing this. So we had the mean, and here's 77. Right, let me make this 50, 60, 70, 80, 90, 100. So let's talk about this guy over here. This guy is right here. What is this distance? From 100 to 77, what is the distance? So to find the distance, I'm going to do 100 minus 77. So this distance equals 23. Right? So if you're 100 and you're walking to 77, that's 23. So again, 23, 23, 23. What about 90? This guy, how many steps does he have to go to 77? Right? So if you do minus 77, you get 13. How about 60 to 77? Well, we'll put 77 on top, so it's going to be 17. So this is 17. This is 13. Right? And then 50. 50 to 77. Right? So we do 77 minus 50, we get 27. So let me do the rest. because we have to do all of them. 17, 17, 27. So those are our distances, right? Now, what do I do with these numbers? Like all these distances? Well, we have to add them. So we have to add these numbers. So I'm going to take these numbers and I'll put it over here. So 23, 23, 23, 23, 13, 17, 17, 17, 27, 27. We're going to add them again. So in your calculator, 23 plus 23 plus 23 plus 23 plus 13 plus 17 plus 17 plus 17 plus 27 plus 27. Enter, we get 210. So we're going to take 210 divided by 10, and we get 21. So the MAD is 21. So what that means is that on average, right, the numbers are 21 units away from 77. Let's do the second one. So for class 2, this is class 2. Remember the mean was 770 again. We divide by 10 and we get 77. So let's draw that again. So here is 50, 60, 70, 80, 90, 100. Yes? And we have 77, which I'll put over here. Right? 77, the mean. Now, we're going to, again, find the distance. Look at 100. So, if you are at 100 and you walk to 77, that's how many? That's 23 steps, right? So that's minus 77 is 23. 90 to 77. So if you were to walk to 77, you would walk 13. 85, which is here, and you walk 77, that'd be 8. And then 80 to 77, that'd be 3. And then 75 to 75, which is here, to 77, that would be 2. Right, but this is just 2. That was 3. This was 8. This was 13. How about 70? 70 to 77 is only 7 units away. 60 to 77 is 17 units away. And then again, 60 to 77 is 17. And lastly, how about 50? 50 to 77 is 27. Right, so who's closer to 77? These group of people or these group? Which one's closer to 77? Well, these guys are closer. Right, so let's add them up. We're gonna add all those numbers again. We're gonna go 23, 13, 13, 8, 3, 2, 7, 17, 17, 27. So we're gonna add them again. 23 plus 13 plus 13 plus 8 plus 3 plus 2 plus 7 plus 17 plus 17 plus 27, and we get 130. So we're going to take MAD. The mean absolute deviation is 130 divided by 10, which is 13. So notice that this MAD is 13. And this MAD was 21. Why is this 21? Because they're far away from 77. And this one, look how close they are. They're closer to the mean, right? Which means there's less of variance. Okay. Let's do. I don't know if I want to do this one. Let's do this one. Okay, so what I'd like you to do is copy. We're going to copy the problem first, and then we're going to do this. So 2013. We got to find the mean. First of all, we find the mean. right? So we're going to do 15 plus 17 plus 14 plus 21 plus 18, right? So we have to find the mean. So 15 plus 17 plus 14 plus 21 plus 18, we get 85. And then we have 1, 2, 3, 4, 5. So we're going to take 85 divided by 5, and that equals 17. Okay, so we can draw a number line just so that you can see. You don't have to, but I want you to see. So let's make 14, 15, 16, 17, 18, 19, 20, 21. We don't need any. So the mean is 17. So over here, I'm going to write the mean is 17. Draw a little flag. Let's put the other numbers. So there's a 15. Here it is. There's a 17. Here it is. There's a 14. Here it is. 21 and 18. So we write the numbers down. We have a 15. We have a 17. We have a 14. You know what? I'm going to put them in order. No, actually you don't have to. Right, let's just do it like this. 15, 17, 14, 21, and 18. So this is 2013. I'll put a little box. So now our mean was 17, right? So don't forget. So we're going to go over here. We're going to put 17 on top. We're going to subtract, right? So 15 to walk to 17. How many steps is it? So we're going to do 17. This 17 right here. I'll change colors. We're going to do 17 minus 15, which is 2. And then 17 minus 17, which is 0. 17 minus 14, which is 3. So 21 minus 17, which is 4. And 18 minus 17, which is 1. What's the next step? Now we're going to find the MAD. We do 2 plus 0 plus 3 plus 4 plus 1, which is 2, 5, 10. And then we do 10 divided by 1, 2, 3, 4, 5. And the MAD is 2. So the MAD is 2. It's a very, very small number because they're really, really close. They're really close to the mean. Okay, let me do 2014. The line, I'm confused. And let's do 2014. In 2014, we have to find the mean first. We're going to do 20 plus 9 plus 34 plus 2 plus 35. So we're going to do 20 plus 9 plus 34 plus 2 plus 35. Enter. We get 100. And then we do 100 divided by 5. And the mean is 20. Don't forget this number. All right, so now I'm going to draw a number line. Just like I did on top. It's going to be a little bit bigger. Right, so our small, so we're gonna, I'm gonna stretch that out. So we have 13, 13, 12. So we have 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So here's 9, here's a 20, right? Here's a 20, here's a 9. Now we need a 34. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. You don't have to do this number line. I'm just showing. So there's a 4 there, and there's a 2. I forgot. Oh my God, there's a 2. 9, 8, 7, 6, 5, 4, 3, 2. Right here, there's a 2. And then there's a 35. What is our mean? Our mean was 20, right? So I'm going to put a flag, and I'm going to write mean. Now, we have to figure out how far they are. So the 2, how far is the 2 from 20? The 9, how far is the 9 from 20? The 20, how far is the 20 from 20? So I'm going to put these numbers down. So 2014, I'll make a box. So we had the 2, we had a 9, we had a 20, we had 34, and we had 35, right? So what was our mean? So remember our mean was 20. So from 2 up to 20, how many units is it? It's 18. From 9 to 20, it'd be 11. From 20 to 20, how much is that? 0. From 34 to 20 is 14. From 35 to 20 is 15. Right? So now we have all these, the distances, we have to add them up. So we're going to go 18 plus 11 plus 0 plus 14 plus 15. And that equals 18 plus 11 plus 0 plus 14 plus 15. That's going to give us, oh look, a very small number, 58. And we're going to divide by how many? 1, 2, 3, 4, 5. And 58 divided by 5 is going to give us 11.6. So and here is the math. So notice that 2014, they were further away from the mean, right? Because look, their distance are very far. They're very far from the mean. In 2013, if you remember, I go up. Look, they're very close to the mean, right? So the distance in 2014, it was a little bit bigger. Okay, so now the question now says, right, this was, there is no question, well, I'm asking you, I guess, which is the better player, the player from 2013 or the player in 2014? The player in 2013, every time he came, he gave you 14 points, 17 points, 15, all the numbers were the same. The player in 2014, look, sometimes he gave you very little, sometimes he gave you a lot of points, so he was very inconsistent, right? It was not the same quality of player every time he came to play. Okay, there was no consistency. So, and that's, during which year was Mr. Smith more consistent? Well, he was more consistent in 2013, right? The numbers are closer to each other. What does a low mat tell you about the data? A low mat tell you that there was less variety, okay, in the data. Like the spread was smaller. And the high mat tells you that the numbers were further away from the mean. Okay, so again, we'll do a couple more. All right, so problem 1, number 1, find the mean. So first we have to add all these numbers. There's no going to have to find the mean. Right? So take your calculator and add 45 plus 47 plus 56 plus 48 plus 46 plus 52 plus 57 plus 52 plus 45. Enter. We have 448. We're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide that by 9. And our mean is going to be 49.77. That's what we're going to, actually, it's going to be rounded to 49, because in the calculator it's 49.7777, right? So we're going to use 49.78. Okay, so that's our mean. Now we have to find the MAD. Okay, so find the MAD. Let me bring everybody. Let me see if I can bring. No, I'm not bring. Let me bring these guys down. Bring this guy down. Bring that. All right, so now we found the mean. And you're going to take this number over here and subtract. Right? So we're going to have to do 49.78 minus 45. 49.78. So again, if it's easier if you put, if the number is bigger, then you put it on top. So here I put it at the bottom, right? Because 56 is bigger. 49 is bigger. I put it on top. 49 is bigger. 49 is smaller. Again, we gotta subtract all these numbers. 49.78 is smaller. 49.78 is smaller. 49.78 is bigger. So we're going to subtract. So now we take a calculator, okay, and subtract 49.78, right? Our mean minus 45, because I find the distance. So this would be 4.78. This would be 2.78. This would be 6.22. This would be 1.78. This is going to be 1.78. This is going to be 2.12. This is going to be 7.12. This is going to be 2.12. And this is going to be 46, 47, 48, 49, 4.78. Okay. This is actually wrong. I don't know what I was thinking. 1.78. This is, no, this is 5.78. The rest, okay. So how do we find the MAD? Right, to find the MAD, we're going to add all these numbers, and I'm actually going to write it for you. So 4.78 plus 2.78 plus 6.22 plus 1.78 plus 5.78 plus 2.12 plus 7.12 plus 2.12 plus 4.78. So I'm going to put that in your calculator. 4.78 plus 2.78 plus 6.22 plus 1.78 plus 78 plus 2.12 plus 7.12 plus 2.12 plus 4.78, and that's going to give us 37.48. And what do we have to do with that number? We're going to take 37.48 and we're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9. So the MAD is going to be about 4, yeah, 4.16. That's our MAD. Okay, the MAD is small, which means our numbers are together, right? They're very together here. So we'll do one more. Again, this says, the scores below represents Amanda's science test scores. Would you say she's a consistent or inconsistent test taker? So does she always get the same grade, or does she sometimes get a lot of different grades? Well, we can see that she's not consistent, right? So I'm going to write not consistent. And if she's not consistent, right, the MAD is going to be high. The MAD's going to be up, big number. Well, not bigger, but so if you look at the, I mean, if you make a little number line, so let's say 20, 30, 40, 50, 60, 70, 80, 90, 100. So we have a 20, we have a 90, we have a 25, we have a 100, and we have a 30. Well, let's find the mean first. So the mean is 20 plus 30 plus 50 plus 90 plus 100. 20 plus 30 plus 50 plus 90 plus 100. Enter. So that's, well, 20 plus 30 plus 50 plus 90 plus 100. Enter. 290. So equals 290. 290 divided by 1, 2, 3, 4, 5. And the mean is 58. So let me put a little flag on 50. That's 50. This is 60. 58 right here. 58. So do you think these numbers, the 20 is close to 58, the 30 is close to 58, the 90 is close to 58? They're very far away. So the MAD is going to be a high, big number. So let's find the MAD. So first, we can put the numbers 20, 30, 50, right? 20, 30, sorry. 20, 30, right? 20, 30, and then we have a 20. I want to do it in order. 20, 25, 30, 90, 95, 100. 95, 100. Right, so we have. And then what are we going to do? Well, we're going to take the mean, and we're going to subtract. So remember, if it's bigger, it goes on top. So 58 is bigger, so we put it on the bottom, at the top. 58 is bigger, put it on top. 58 is bigger, put it on top. Okay. 58 is smaller, we put it at the bottom. Right, and subtract, use your calculator. Okay, so these are our answers. Now, how do we find the MAD? Right, so we have to take these numbers, right, the 38, 33, 28, 32, 37, and the 42, and we're going to add them in the calculators. 38 plus 33 plus 28 plus 32 plus 37 plus 42. Enter, we get 210, so this is equal to 210. And we're going to divide by 1, 2, 3, 4, 5, 6. We're going to divide that by 6 now. 1, 2, 3, 4, 5, 1, 2, 3. Oh no, I forgot a number. 1, 2, 3, 4, 5. There's 6 numbers. I did this incorrectly. There is a 20, a 30. I forgot the 25 over here. Right, so I have to erase this. So the mean, right, we're going to add the numbers, is 20 plus 25. I forgot there's a 25 here. Plus 30 plus 90 plus 95 plus 100. So there's 6 numbers. So 20 plus 25 plus 30 plus 90 plus 95 plus 100. That equals 360. We gotta take 1, 2, 3, 4, 5, 6. 360. We're gonna divide that by 6. And we get 60. I'm gonna draw a number line just to show you. You don't have to this. This is just to give you an idea. Let's say 20, 30, 40, 50, 60, 70, 80, 90, 100. So we have, let's put the numbers, we have a 20, right? Right here. We have a 25, and I'll put it right here. We have a 30. We have a 90. We have a 95. We have 100. What's our mean? Our mean, and I'll put a red flag here. Here's our mean. 60. Now, do you think these numbers are close to 60 or are they far away from 60? Well, they're pretty far away from 60. Right? So let's find out how far away. So we're going to put these numbers again. 20, 25, 30, 90, 95, and 100. And we're going to find the difference. So we're going to take that. So 20, if you were to walk to 60, how many steps? Well, if you subtract, you get 40. 25, if you want to walk to 60, how many steps? Well, subtract 35. 30 to 60, how many steps? Well, subtract. So if 60 is bigger, put it on top. Now if 60 is smaller, we put it at the bottom. So from 60 to 90 is 30, right? From 95 to 60 again. And then 100 to 60 is 40. So are they close to 60? No, they're not. So let's find the MAD. So finally we get to find the MAD. To find the MAD, we have to add these numbers. We're going to do 40. So I'm going to do the MAD. 40 plus 35 plus 30 plus 30 plus 35 plus 40. Let's add them up. 40 plus 35 plus 30 plus 30 plus 35 plus 40. Enter. We get 210. I'm going to take 210 divided by 6. 1, 2, 3, 4, 5, 6. And we get 35. So our MAD, look, it's pretty big. They're not close. They're on average 35 units away. So is she a consistent test taker? No, she's not. Okay, so that's your video.